Hey guys, welcome to our video in which we're going to be introduced to the law of sines. Our learning target for this is I can use the law of sines to find missing angle measures and side lengths in an oblique triangle. Now, in the past, we've used trig functions like sine, cosine, and tangent to find missing side lengths and angle measures in only right triangles. So we can't use those like we have in the past. But what we have now is two new laws. One of them is the law of sine, and we will learn the law of cosines later, that we can use with oblique triangles, which are just triangles that do not have a right angle. Okay, so starting with the law of sines is just basically a big proportion. So it is true that the side length to the sine of its opposite angle is equivalent to any other side length to the sine of its opposite angle in an oblique triangle. So if we fill in the law of sines here, we will put in the side length A over the sine of angle A, the side length B over the sine of angle B, and the side length C over the sine of angle C. It is important to note that if we name a triangle A, B, C, remember we name triangles based on their angles, that the sides opposite the angles have the same letter, they are just lowercase. So of course, across from angle C, we have lowercase side C, and you can look around the triangle there. So please be cautious that you are using appropriate lowercase or uppercase letters. Okie dokie. Now, we won't fill out the whole proportion and solve it because that just wouldn't work. We only use parts at a time. So for instance, I might know some information about side A, side B, and or angle B. So I would be setting a proportion, of course, with only one equal sign. Well, in order for this to work, that means I must have only one unknown, and there are three cases in which that works. So down here, and I'm going to draw them on our little triangle over here. The first case would be if I know two adjacent angles that are next to each other. So let's say here and here, and a side opposite of them. So here. Okay, so these little acronyms will remind you when you did triangle similarity. So angle, angle, side. Or if I know two angles and their enclosed side, so instead of having that side I used before, it would be the side between them. Or if I have two sides and their angle that is outside of them. So let's say I had side A, B, okay, and an angle that's outside of them would be A, or I could use B. All right, and it'll be easy to see if you can use the law of sines because remember, you can only have one unknown. All of these, we will be using the law of sines today, so we already know that. All right, let's us get to a couple examples. Use the law of sines to find the remaining angles and sides in the triangle. The first thing I'm going to do is I do not really need to use the law of sines to find the measure of angle A because I know that I have angle C measures 102 degrees and angle B measures 29 degrees. So 102 degrees plus 29 degrees, let's see, that gives us 131 degrees. Okay, so if I subtract that from 180, I see that my remaining angle here, angle A, should be 49 degrees. Okay, so that's one of our unknowns. We know that the measure of angle A equals 49 degrees. So I did not have to use the law of sines for that. However, I will have to use the law of sines for the side lengths. Okay, so remember we can only have one unknown. So let's say we're going to start with side length A. That means I would have to know angle A, which is wonderful because we have found that. And then I have to know both the side and angle of my other part of my proportion because my A is what I'm looking for. So A over the sine of 49 degrees, set that equal to, we have to use angle B and side B because those are the only two we know, both of them. So side B is 28 feet and angle B is 29 degrees. So we're going to go over the sine of 29. And now we're just going to simply solve for A. And with proportions, you can definitely diagonally multiply and divide. So this would be A times the sine of 29 degrees equals 28 times the sine of 49 degrees. And to get A by itself, I'm going to divide by the sine of 29 degrees. Now I'm going to do that in my calculator. What I'm going to do is I'm going to type 28 times the sine of 49, and then I'm going to put divide by sine 29. Because I'm measuring angles in degrees, I need to make sure I'm in degree mode. Looks like I need to change that. Okay. And I'm going to type 28 times the sine of 49. And then I'm going to divide that by the sine of 29. And whoopsies. And I get approximately 43.59. Let's round to 2 decimal places here. 43.59. So A is approximately 43.59, and we're talking feet. Okay, so I have found side A. I still need to find side C. So what I suggest doing is just keeping this part of your proportion, because you were given 28 feet, whoopsies, and the sine of, or you're given 29 as the angle. So I would just keep that, and I'm going to extend this proportion, and I'm going to put over here equals C over, so looking for side C, and the angle C is 102 degrees. So now I'm going to solve this proportion. Okay, so I am going to end up taking, if you just cross, multiply, and then divide by the other, what we will end up doing is we will end up taking 28 times the sine of 102 degrees and dividing by the sine of 29 degrees. So going back to my calculator, 28 sine 102. I'm just going to go ahead and press enter there, and then divided by the sine of 29. And I get approximately 56.49 feet. That is C. So C is approximately 56.49 feet. And we have solved that triangle. Okay, guys, I hope that gives you a little idea about the law of sines, and we're going to do more practice in class tomorrow.